One day I walked out into the parking lot and saw a puddle under my van. It was coolant, no big deal, probably just a hose clamp that needed to be tightened. But try as I might, I couldn't find the leak. I could see a drip coming off the motor mount, and I knew there was a freeze plug behind it, so I began to suspect that's what was leaking. And I considered myself lucky that I found that leak because 14 years ago I had a freeze plug blow out with no warning at all, and it was only by luck that I looked down and saw the temperature gauge going off the scale. Lucky for me, I was just going down a long driveway at the time. It would have been a disaster if it happened out on the highway. So if you suspect a freeze plug problem, get the vehicle home or into a shop as soon as possible. My local garage quoted me $650 because replacing that plug behind the motor mount was, they said, a nightmare. And oh, by the way, if one is bad, the others are probably about to go too. So $50 a piece for any additional ones. There are 2 plugs per side on this engine. 2 in the front, so let's see, that's only $900. Then there are 3 additional plugs on the back of the engine that aren't even accessible without pulling it. Fortunately, those tend not to leak, or so I've been told. It might be possible to do this job without lifting the vehicle. I put mine on ramps about 6 inches high and found that to be the perfect height. Jack stands can be used at the front lift points, but they're a bit in the way. And one thing I've noticed when lifting my van at the front cross member is that it wants to come off the jack if the wheel gets any higher than about 4 inches. I don't think the jack head gets enough friction on the metal cross member even if you clean it well. Now a piece of wood between the two might help, but I decided to lift from the side lift point. Now the other safety issue here is the engine, and this one weighs about 425 pounds, plus another 200 for the transmission. I'll be removing the motor mount and supporting the engine while I work, so I'm taking every safeguard. Take a look at this shot from midway into the project. I've secured the engine with a 2x4 at the engine side lift point, which I'll cover later. I've got a 2x4 I cut to support the engine on the subframe cross member, and I threw a piece of wood into the 2-inch gap between the oil pan and the cross member. In addition to all that, I have a floor jack under the oil pan just in case, so I think I'm pretty well covered here. Now regarding the oil pan, I can press it in with just my fingers on the bottom, so it's made of surprisingly thin metal. And I don't want to lift the engine there because the oil pickup lives very close to the bottom of the pan and it would probably get damaged. My Haynes manual says the engine can be lifted here with a 2x4 under the pan, but my GM manual says don't do it. And there are guys that have done this even with the board and afterwards found their oil pan gasket to be leaking, which is not too surprising considering that the pan gasket may have been compressed by the weight of the engine. So there you have it, a 600-pound engine and transmission that have to be handled with kid gloves. First I removed the bolts holding the motor mount to the pedestal. These are all accessible using simple tools, but access can be difficult. I used a deep set socket on the nuts and an open-end wrench on the bolt heads. I had to reach over the transmission shifter to get a wrench on the bolt closest to the driver's side of the vehicle. Then I removed the nut on the motor mount center bolt. I need to lift the engine just enough to get the bolt out, and the best way to do that is to use the side lift point that is cast on the side of the block. Clean any grease or dirt off of it first. Here I'm putting an 11-inch 2x4 up to the lift point, which needs to align with the center of the 2x4. And I put the jack on the center of the 2x4 as well, so everything's aligned. Otherwise there'll be a sideways thrust on the jack as you lift, and that could knock it over and allow the engine to fall. And of course I still have the floor jack under the oil pan with the board as a backup. I lift just enough to release the center bolt. Too much and it may bind from upward pressure. The motor needs to come up a bit more to get the motor mount out. That scary sound was the motor mount sliding out. Now I need to secure the engine because unfortunately that 2x4 and jack on the side lift point is right in the way of where I need to be working. And I found it best to use a 6-inch 2x4 from the oil pan bolts to the top of the subframe cross member. I make sure I get the board under 2 bolts, which prevents the oil pan gasket from getting compressed. I expect this is supporting maybe 200 pounds max. I keep about 40 pounds of lift on the oil pan with a board, but no more than that. Now I can get to the mount bracket to block bolts, which are inaccessible when the motor mount is installed. Again, simple tools do the job, just a deep set socket and a ratchet. So here it is, the leaky freeze plug. Very strange that it has RTV smeared all around the outside. That's a mystery for now, but I know this plug was replaced 14 years ago. I've heard several people say that the water jacket on these engines can be drained by removing the knock sensor, but on mine it just screws into a blind hole. So when the freeze plug pops, there's going to be a big gush of coolant, about 1.5 gallons. You don't want any of that in your eyes, so wear goggles with side protection. With the engine cool, I remove the radiator cap to release the pressure, and then I put it back on, which hopefully will slow the flow of coolant when the plug finally goes. Now here's my basic tools for the job: a long pounding tool and a 4-pound hammer, both from Harbor Freight. My 16-ounce hammer had very little effect. The idea is to pound the plug at one side and have it rotate in the hole, but most of the time it ends up in the block and it really needs to come out. Plumber's pliers may work, but I like these pry bars from Harbor Freight. They have a good angle to get at the plug. Now here's a couple of adjustable ones, one from Craftsman on the left and Northern Tools on the right that might also do the job. If the plug is rotten at the center, then it will probably just break through, leaving a lot of torn and jagged metal just waiting to cut your fingers, and the outer ring will still be solidly stuck in the block. So how are you going to get that out? Well, if the plug was installed properly, it will be just a bit proud of the block or flush with it, and you should be able to get a pounding tool on the edge and collapse one side like this one. I was able to collapse one side a bit, which loosened it and allowed my penetrating oil to work better. As long as you are collapsing in towards the center, you should be okay. What you don't want to do is pound the edge of the plug straight in and gouge the wall of the hole. Now, if you have to pound it straight in, then at least use a brass drift. Now, if you haven't gotten this thing out by now, you're probably contemplating calling a tow truck to haul the whole thing down to the nearest junkyard. But you can try cutting on it with a hacksaw blade or grinding it with a Dremel tool to weaken it. Again, don't gouge that block wall. I did hear about a guy who used a propane torch to burn out the sealant around the plug, which allowed penetrating oil to work better. Just don't set your vehicle on fire. And with the idea that if one plug is bad, the others probably are too, I decided to replace the other one on this side, but when it came out, it was solid as a rock. So how could one be rotted through and the other still good? I know this one was replaced 10 years ago, so it was only 4 years older than the one that was rotted through. Another mystery. Anyway, clean out the holes and remove any corrosion with emery cloth. Now, where freeze plugs are concerned, some people like brass and others like steel. Some use sealant and others don't. Some people call them freeze plugs and others expansion plugs or frost plugs, but the idea that they are designed to protect the engine from cracking if it freezes is not correct. These holes are just part of the casting process, but that's not to say if your engine freezes that one of these might not pop out and save the day. I decided to replace my steel plugs with brass because brass doesn't rust and they're a little easier to remove and install. Regarding sealant, I decided to try one with and one without, and the preferred sealant is Permatex Aviation Formagasket. This dries tacky, which may be why it works in this application, as there may be different expansion rates between the block and the freeze plugs. This stuff is not pleasant to get on your hands or your tools, but it cleans up easily with alcohol. RTV by the way, is not recommended in this application. To install, you can use a deep set socket. Just make sure it fits the plug around the inside edge. If the socket's too small, it may distort the shape of the plug. Also, you don't want to be banging around on the edge or you may bend it. A 3/8" drive socket fits nicely on the end of this tool. I'm fortunate to have a compressor and an air hammer, and that's what I used on the first plug. Again, the 3/8" drive socket fit pretty well on that. I used Permatex sealant and it went in pretty hard, even with the air hammer. Now for the front plug. There's no room to swing a hammer in here, but the fact that the front plug is under the motor mount is actually a blessing in disguise, because the motor mount holes can be used to press in the plug. There's a triangular plate of 3/16" steel between the block and the motor mount bracket that I assume is there to reinforce the bracket. This thing only fits one way, so I mark it when I take it off. When it's on wrong, it looks right, but when you start to tighten down the bolts, they bind. As I'm wrenching here, it's a bit hard to see, but it's just a couple of discs from a Harbor Freight bearing installation kit with the metal triangle on top. There may be other objects you could use, but you get the idea here. Use the bolt holes in the block to drive the plug in. I also found that a stick mirror was pretty helpful to see the back of the plug as it was going in to make sure it didn't bind. You may need longer bolts for this. The ones I used were 2¼ inches long. Now, if I didn't have this metal triangle, I might have tried making something out of wood cabinet quality plywood or had something made from 3/16" steel. It might be possible to use the motor mount bracket itself to drive the plug in. This impact hammer from Craftsman might also work. OEM has a freeze plug installation tool with a swivel head and a bend in its shaft that allows installation at an angle, but none of my local parts stores had it, either for loan or for sale, and I'm not sure how much of an angle it would work with. Now, I've even heard of a guy who installed a freeze plug by using a pry bar. I guess if you cut a 2x4 of the right length and placed it at the right point as a fulcrum, that might work. In the worst case scenario where you couldn't get the plug installed, you could try this expansion plug from Dorman temporarily, but it's not recommended long term. Well, finally the job was done. The problem was fixed. I'd saved a bunch of money. The sky was blue and life was good. But within 2 days, guess what? I had a new leak. It was a re-leak. It was a leak from the same plug and from the same exact place. And the gray stuff you see here is JB Weld that I smeared around the outside to stop it, but that didn't work. So what went wrong with this job? To find out, I'd have to tear it back down and do it over. And looking at the other plug, even though it wasn't leaking, something didn't look quite right. It didn't seem to be driven in quite straight, and there were gaps between the plug and the block. Might as well do that one over too. But no more Mr. Nice Guy. It's time to get serious. This OTC freeze plug installation tool is well worth the money, and the ball end means business when knocking out freeze plugs. The disc keeps the plug in place during installation and drives it in flush to the block, but it's not very good at getting the plug started. And it could probably be used with a hammer if you don't have an air gun. Now, I've been hammering at this plug a bit, and it's just about ready to go. Now all I've got to do is wedge the old plug out, making sure not to gouge the block. I keep my goggles on as there's still coolant up in there dripping. So as I said, this is a great tool for driving in freeze plugs, but not for starting them. You really have no control over it like you do when using a socket. The problem here is the exhaust is in the way and its hardware is all rusted, so I can't get a straight shot at it. So having the socket swivel a bit on the driver is just what I need. I get it started and then switch over to the OTC disc to finish it up. Perfect. You could do it just with the socket. Just make sure you don't drive it in too far. And the sealant cleans up with alcohol or acetone. But we're not done yet. While I was working, I thought I saw a freeze plug up in the water jacket. I poked it and prodded it, but it didn't move, so I wondered if it was maybe a part of the block. But then it dawned on me that it was the freeze plug that was replaced by my erstwhile mechanic some 14 years ago. He had just knocked it into the block and left it there, and it corroded and rusted itself into place, slightly overlapping the hole, and it was trapping sediment over the plug that rotted out. And if you ever blown out a heater core with compressed air, you know what can be in there, and that stuff usually ends up in the water jacket. So now I have my explanation as to why the front plug was corroded through and the other one was not. And now you know why an old freeze plug should never be left in the block. Clean out the water jacket as best you can. You don't get a chance that often. And now about that leak. I didn't see the problem till I took this picture, and then not until I blew it up and looked real close. I believe I see chisel marks gouging the wall. This actually looks worse than it is. You can barely see it with the naked eye or even catch a fingernail on it. But it's big enough to let coolant pass the freeze plug and cause a leak of a drop every few seconds. This may also explain the RTV on the outside of the plug. When erstwhile mechanic discovered it was still leaking, he just smeared it on. How it held for 14 years is a mystery to me. Now the problem might have been taken care of if I had used sealant, but then again maybe not. If the sealant dries tacky, the hot coolant might eventually force its way through. I didn't want to take a chance on another failure, so I cleaned it with acetone and worked some JB Weld into the gouges, and then later sanded it flush. So as they say in the manual, and I hope you get many more miles out of your shiny new freeze plugs.